In this video, we'll talk about polynomials and we'll do operations on polynomials. First of all, what is the recipe for a polynomial? So this is an example of how a polynomial looks like. Ax to the third plus bx to the second plus cx plus d, where a, b, c, d are coefficients, they are numbers, and x is the variable, and x to the highest power, so the highest power of x, it's the degree of the polynomial. So now, a few examples. A monomial has only one term, so x is a monomial. X minus 4 has two terms, has the name binomial. 5x to the second minus 3x plus 5, it's a trinomial. So let's discuss a few operations with polynomials. So like with numbers, we have addition. So keep in mind that x plus x is 2x. Why? Well, 1x plus 1x, right? They're 2x. Or I usually draw an apple plus one more apple is going to make 2 apples, right? So keeping that in mind, let's add the like terms. So 3x squared plus 2x minus 5, this trinomial, plus x squared minus 6x, this binomial. So what do? Well, first of all, I'm going to write the terms again. So 3x squared plus 2x minus 5 plus x squared minus 6x. I dropped the parentheses because it's just a plus in front of them, so there is no, we don't have to make any changes. Now 3x squared plus 1x squared, because in front of x squared it's a 1, that makes it 4x squared. They are alike. 2x minus 6x is negative 4x. And then negative 5 is by itself, so we just copy it. So the final answer is 4x squared minus 4x minus 5. The next problem, it's very similar. It just has fractions in it. So 2 over 3x squared plus 4 over 3x squared are alike. So we'll just add the fractions. 2 over 3 plus 4 over 3. Well, they have the same denominator. We copy it, and 2 plus 4 is 6. So we get 2. So we get 2x squared. Now, other like terms are negative x with plus 9x. So negative x plus 9x, that's plus 8x. And 1 over 8 minus 1 over 4. So 1 over 8 minus 1 over 4. We have different denominators, so we are going to multiply the second fraction by 2 over 2. So we get 1 over 8 minus 2 over 8. That makes it negative 1 over 8. So minus 1 over 8. And this is final answer. Let's take a look at some subtraction problems. So first of all, let's keep in mind that a minus b, it's actually a plus the opposite of b, so negative b. So when we have a minus b, we write like this. We add and we put the opposite of b. So any subtraction is going to become an addition. So let's keep in mind that opposite of x is negative x, opposite of negative 2x is 2x, opposite of x minus 3, well, that would be negative x minus 3 like this, which if we open the parentheses is going to be negative x plus 3. We change all the signs. So now based on this information, let's do example 3. So 3x squared plus 2x minus 5 minus 4x squared minus 7x plus 2. So what do? We add the opposite. So we change all these signs. So basically our problem is 3x squared plus 2x minus 5 minus 4x squared plus 7x minus 2, right? We add with the opposite. So now we are actually adding like terms like we did before. So 3x squared minus 4x squared is negative 1x squared or negative x squared. 2x plus 7x, that makes it 9x. And negative 5 minus 2 is negative 7. So this is the final answer of the subtraction. Let's take a look at example 4. So again, we have a subtraction between the quantity 6x squared y minus 2xy plus 3 and the quantity x squared y plus 3. So again, we do add, and then we write the opposite of all the terms inside the parentheses. So we have 6x squared y minus 2xy plus 3 minus x squared y minus 3. The first term, it's alike with negative x squared y. So 6x squared y minus 1x squared y, it's 5x squared y. Minus 2xy, there is no like term. And 3 minus 3 is 0. So this would be the final answer of the subtraction. Let's do a few multiplication problems. So the main one that it's very important to know is that x times x, it's x to the second. Why is that? Because x is to the first times x to the first, we copy the base and we add the exponents. So 1 plus 1 is 2. So now let's do example 5. So we want to multiply 3x to the 7, y to the third, by 5x to the third y. So 3 times 5, it's 15. Then we have x to the 7 times x to the third. We copy the base and we add the exponent, 7 plus 3. And then we copy the base and we add the exponents, 3 plus 1, because here is 1. So then we get 15, x to the 10, y to the 4. Let's do another problem. 2x times the quantity x minus 3. So we have to multiply each of these terms. 2x times x, that's 2 times x to the second, because x to the first times x to the first, it's copy the base and copy the base and add the exponents. Then 2x times negative 3 is negative 6x. Final answer. The next problem. Negative 4xyz times x squared y. So negative 4, x to the first times x to the second, it's x to the third. Y to the first times y to the first, it's y to the second, and z. And then negative 4 times negative 4xyz times negative 1/2 xyz is plus, right? Negative times negative, positive. 4 times 1/2, it's 2. And then x times x, it's x to the second. Y times y, it's y to the second. And z times z, it's z to the second. Final answer. Now let's multiply two binomials. So we have to multiply each term by each term. So x times x, it's x squared. X times 4, it's plus 4x. Negative 3 times x is negative 3x. And negative 3 times 4 is negative 12. We can still add these two middle terms because they are alike. So we get x squared plus x minus 12. Final answer. And this method, you probably recognize it from calling it FOIL. Why? Because what we did, first we multiplied the first terms, x with x. Then we multiply x with 4, which were the outer terms. Then we multiply negative 3 with x, which were the inner terms. And then we multiply negative 3 times 4, which were the last terms. So that's why it's called FOIL. Now let's multiply a binomial by a trinomial. So again, we have to multiply every single term from the first parentheses by every single term from the second one. So 2x times 2x squared, that's 4x to the third. 2x times negative 4, that's negative 8x squared. 2x times negative 3, that's negative 6x. Now let's multiply negative 1 with each term. So negative 1 times 2x squared is minus 2x squared. Negative 1 times negative 4x, that's plus 4x. And negative 1 times negative 3, that's plus 3. So we still have some like terms to add. 4x to the third is not alike with anything else. But negative 8x squared minus 2x squared is negative 10x squared. Negative 6x plus 4x, that's negative 2x. And then plus 3. Now let's take a look at this product, x minus 3 times x plus 3. So again, we do the FOIL. X times x, it's x squared. X times 3, it's plus 3x. Negative 3 times x is negative 3x. And negative 3 times 3 is minus 9. These two cancel out and we end up with x squared minus 9. So that's why here it says difference of two squares, because what we actually get is x squared minus 3 squared, so exactly a difference of 2 squares. So if you learn this, you can always find, for example, if I give you x minus 4x plus 4, you can immediately say it's x squared minus 16 because of the process of foiling, and then the middle terms get cancelled. And this, let's call it example 10 star. And from here, you might be familiar with the formula a minus b times a plus b is equal to a squared minus b squared, the difference of 2 squares. And now let's take a look at x minus 4 squared. So if you had to calculate x minus 4 squared, well, we remember that x squared means actually x times x, right? So from the same principle, let's say x minus 4 squared, it's x minus 4 times x minus 4. And now I'm going to multiply each term. So x times x is x squared. X times negative 4 is negative 4x. Negative 4 times x is negative 4x. And negative 4 times negative 4, that's plus 16. So if we add the middle terms, because they are alike, we get x squared minus 8x plus 16. Or in other words, we got the first term squared, right? We got x squared. We got the second term squared, 4 squared. But we also got 2 times, or negative 2 times x times 4. So we got 2 times the first term times the second term. And this is called perfect square trinomial. And let's take a look at the last example. So again, x plus 5 times x plus 5, it's x plus 5 squared. And if we multiply, we get x squared plus 5x plus 5x plus 25. So we got x squared plus 10x, because these two are alike, plus 25. We basically got the first term squared, we got the last term squared, but we also got 2 times x times 5. And this is called perfect square trinomials. And the actual formula is, if you have a plus b squared, the formula is a squared plus 2ab plus b squared. So you don't have to go and multiply like I did. You can just directly use the formula. If it's a minus b, like it was in example 11, then you'll end up with a squared minus 2ab plus b squared.